my computer. So yeah, I'll do it for another probably like 50 minutes. Just a second. All right, so this is another one from the Saudi Arabia Balkan Math Olympiad team selection test. So not the team selection test for the IMO, but the team selection test for the Balkan Math Olympiad. Oh, this is a Sharky Devil problem. So for those of you that have seen my video on the Sharky Devil configuration, this one I believe should use it. So let's draw the end circle of ABC. And I'll just let I be the end center. All right. So we have D and F. So yeah, whenever you have like a perpendicular from D to EF, this is the Sharky Devil configuration. So I will explain in just a second. All right. So then we draw, so the circumcircle of AEF passes through I, because AFIE is cyclic. Let's draw this a little nicer. So they call it T. We want to show TX is, wait a sec, something's up. The end circle is tangent at D, E, and F. The perpendicular from, oh, it intersects AB at X. Okay, not EF at X. So it's still probably related to the Sharky Devil configuration. Just, okay, so I could call this X. And we want to show TX is perpendicular to TF. Let me delete this actually. Which is the same as showing TX HF is cyclic. So the Sharky Devil lemma says that TH and I are collinear. So I've proved this before on my channel. So yeah, if you haven't seen this, watch the video on the Sharky Devil configuration. I wonder if there's like a really simple proof of that. I did a kind of longer proof on it. But not only that, I mean, yeah, once we know TH and I are collinear, angle ATH is 90 degrees. We want to show TXHF is cyclic.
Sounds like an angle chase.
Yeah, it feels like it. Because angle XHF is AEF. That's an angle chase. Let's see. I am not that smart, so I don't see it right away, but maybe, let's see.
Oh yeah. It's pretty simple. So TFAI is cyclic, right?
Mm-hmm.
And so FTH is half angle A.
Because it passes through I. So yeah, it's really just an angle chase. All right, so we have a bunch of Sharky Devil stuff. So I'm just going to refer to that video on my channel. So by the then we have T, H, and I are collinear. And then it's really just an angle chase. So so angle FTH is equal to angle FTI, which is equal to angle FAI, which is equal to half of angle A. And then also angle FXH is equal to half of angle A by an angle chase. It's not super hard to see. So and so that means that that's cyclic. So TXHF is cyclic. And so angle T, TX is perpendicular. Yeah, so and so then TX is perpendicular to TF. So yeah, for those of you that haven't seen the Sharky devil idea, basically we can actually show that, I think we can show FH over HE is equal to BD over DC. And I think that's the idea behind proving it. So in fact, triangle BFH is similar to triangle CEH. There's a lot of structure here. So yeah, BFH is similar to CEH. It's not hard to see that from angle chasing and projective GEO. So FH over FB is HE over EC, but FB is the same as BD and EC is the same as CD. So FH over HE is BD over DC. And then we can use that. Let me see. So trying to remember, yeah, like how we end up showing TH and I are collinear. So basically, like you can use kind of spiral similarities. So like TH and I are collinear. If and only if T, since H breaks up the segment FE in the same ratio that D breaks up the segment BC. And also by angle chasing, you can see that triangle TFE is similar to triangle TBC. So basically it turns out that TH and I are collinear if and only if TD and J are collinear. And I show that in a different way in the Sharky double video. So yeah, it's kind of a long proof, but I'm sure there's a shorter one. So yeah, maybe I'll post a link to a site that has that Sharky double configuration. Whoops, I don't want to delete the whole thing. All right, so I will move on to the next problem. All right, so we have a triangle ABC. Angle B is less than angle C. So we want to do it something like this. I is the incenter. D is the intersection of AI with BC, so the foot of the angle bisector. Let's make that more clear, something like this. M and N are on BA and CA, so that BM is equal to BD. and Cn is equal to Cb. That's kind of interesting. The circumcircle, so let me call them M and N. The circumcircle of CMN intersects BC at P. And we want to show DIMP is cyclic. Right, so I'm going to hide some of the excess now. Oops. All right. Let's see. Yeah. So I'm just going to check that that is cyclic. All right. Interesting. It kind of looks like AB is tangent at M, which isn't true. So I'm going to maybe try to move things around just a little bit. Yeah, it's hard to have a great diagram, I guess. But yeah, AB is not necessarily tangent at M. Just remember that.
Not sure if the tangency points of the N circle may or may not be important.
Yeah, I might draw those in. And yeah, that kind of makes it clear that it's not, well, I guess it still could be tangent at M, but yeah, it's not. It's interesting. It's interesting how it's like asymmetric. So you have like the circumcircle of CMN and it cuts BC at P. So you could obviously do the same thing with BMN, right? Although it would intersect it outside the segment. Maybe thinking about both of those at the same time helps, although I don't think so.
So I is still the circumcenter of DMN, right?
I is the, oh, you're saying I is the circumcenter of DMN?
Yeah.
Yeah, by symmetry, that's true. Interesting, because BM is equal to BD and CN is equal to CD. That's a good observation. I did not realize that. Is MN parallel to BC? Or is that just a coincidence? Yeah, MN is like parallel to BC. Let's see, why is that?
Yeah, by the bisector theorem. So BD over DC is equal to AB over AC.
Yeah. So yeah, BM is, so MN is parallel to BC. Okay. By the angle bisector theorem. And is M, this looks cyclic too, AMIN. I think that might just, let's see. Yeah, it's probably like an angle chase that shows AMIN is cyclic. Trying to think. So yeah, I guess AGIN is cyclic. No, I'm sorry, AGIF is cyclic, and I think triangle IFN is congruent to IGM, and so I think from there you could show that that's cyclic. See you, Raffaello. Thanks for joining. Yeah, so yeah, we could start out saying AGIF is cyclic, and then since IMG is congruent to NIF, then from there we get AMIF is cyclic. Actually, maybe. Okay, I guess I'll just draw that. So DIMP.
I mean, like MP should be like equal to NC because it's kind of like a C and MP is a trapezoid.
Yeah, I thought
How do you say
trapezoid.
that? Yeah.
And I think by symmetry, MP is also going to be tangent.
Yeah.
Yeah, which is interesting. Okay, so that is another good observation. Wait, is that obvious that MP by symmetry is tangent to, because I'm trying to think again. I'm just going to assume it for now. But when we do the proof, I'll see if it's, I'll think again if it's obvious. Okay. So yeah, I wonder if we can finish it off like with an angle chase. Whoops. So we want to show, like we could show angle IDC is equal to angle IMP. That might be one way.
Well, if it's symmetric, like IMP should be equal to INC, right?
Yeah.
And yeah, that should be.
And INC is IDC because they're symmetric.
Oh,
yeah.
Yeah. We're done.
I like it. Let's see. So now let's try to think, is it obvious that MP, like, is it obvious by symmetry that MP's tangent because CN was tangent? I guess I'm trying to think.
So I is on the perpendicular bisector of MN, and yeah.
So yeah, so it has to be, and then P is like the symmetric, how did we define? Yeah, oh, P is just the intersection of this. Yeah, okay, so that solves the problem. Ooh, that was fast. All right, so there's actually a number of steps there. So I'm going to, let's see, we didn't really introduce any new points, but I'm gonna, oh, we introduced P. No, oh, actually, never mind. So, all right. So first, yeah, I'll use the angle bisector theorem. So, we have okay, so then that means MN is parallel to BC. And then we can show that triangles IGM and IFN are congruent. So Yeah, first I'm going to mention, yeah, I is the circumcenter of DMN. So yeah, I'll just say BMID and CNID are kites. So that means that ID equals, or IN equals ID equals IN. And so I is the circumcenter of DMN. And then, what's I going to do after that? Yeah, I was going to show that triangle IFN is congruent to triangle IGM. So IG equals IF, IN equals IN, and IFN. So those triangles are congruent. All right. And so, first of all, we know AGIF is cyclic. Then we can use that to show AMIN is cyclic. So angle MIN is equal to angle GIF plus angle MIG minus angle IFN, which is just angle GIF, which is 180 minus angle A. Oh, did I actually need that AMIN was cyclic? I don't even know if I needed that. Maybe that was just extra. Yeah, I don't think I actually needed that. Interesting. So maybe I could just delete. Yeah.
Yeah, only that IM was equal to IN.
Yeah, well, that's just like an interesting fact, but it's not. It's not really needed. Okay. Okay, so since MN is parallel to BC, then MNCP is an isosceles trapezoid. And I lies on the perpendicular bisector of both MN and CP. So by symmetry, NC is tangent did we even need that's tangent?
I don't think we need the tangency.
No.
Either.
Wow. We do not need the tangency. We just need angle. Well, yeah, we don't need the tangency. So, all right. So angle INP is equal to angle INC, which is equal to angle IBC, since that's a kite. And so DINP is cyclic, right? Yeah, I added all these extra steps, like showing that AMIF is cyclic, showing that that's tangent, but yeah, they were not necessary. All right, so I have one last problem, so this will probably be the last one. Oh, this one looked kind of tricky. So we have a cyclic quadrilateral ABCD. Whoops. Let me use this thing. And the perpendicular to AC at D So yeah, I'll stop in a half hour. So if we solve this in a half hour, then I'll end there. And otherwise, I'll just leave it for the viewers. So E, and it intersects a circle at F. And L is the line perpendicular to BC at F. And the perpendicular line to L at A, it intersects the line at G and the circle at H, and line GE. Ooh, this is getting tricky. That's a lot of points. Intersects FH at I and CD at J. And we want to show CFIJ is cyclic. All right, so I am going to draw in some things and then erase some of the excess. Don't know if I drew any of those segments twice, but oops. Hide this. All right. Let's see. So we want to show CFIJ is cyclic. All right. It's a lot of perpendiculars here.
Is GJ perpendicular to AD by any chance?
It looks kind of perpendicular, doesn't it? But no,
it's not.
Interesting. Let's see, CFIJ. So yeah, there's a bunch of different ways of thinking about it. So like we could try to show that JCI is equal to angle BAD. Or we know JCI is equal to BAD.
Is there any way of like marking the right angles?
Yeah. So let's see. I could do this, for example. So let's see all the different perpendiculars. So that's the right angle. I like how it automatically shows you like when it's right. That's pretty cool.
Yeah.
Some nice GeoGebra developers. And then was there one more? The perpendicular.
EA and DF, right?
Yeah, this is perpendicular.
Okay.
See, is it perpendicular to AC? L is the perpendicular to BC, and then the perpendicular to L at A, G and H. Yeah, so those are all the perpendiculars. And so BC and AH are parallel. Let's see. Wait, so JCB is BAD. Yeah, it's kind of like, let's see if I drew that. Let's see, so we can use an angle chase, we can use power of a point. Probably an angle chase looks. I wonder if FC equals FJ. No, I don't think so. It's close, but yeah, not necessarily. Yeah. Or JF and I doubt this is true, but yeah. So angle CFI is CFH is CAH. So we want to show CAH is equal to CJI. Interesting. No, actually, we want to show DH is parallel to JG. Yeah, if we showed DH is parallel to JG, I think that solves it. Yeah. Yeah, it's weird. It's crazy. There's so many like equivalencies here.
Is DH parallel to AB?
I don't think so, but
No. Hey.
let's see. Yeah, there's like a lot of equivalencies here. It's interesting. Yeah, it's like how to cut through all the sort of information. Yeah, is it just an angle chase and you just have to apply it enough times, or is there something like deeper? I guess that's the question. I don't know. Yeah, obviously BC is parallel to AH. So yeah, we could. Oh, I'm sorry.
Yeah, with so many right angles, I'm also kind of trying to look for orthocenters.
Yeah, I was thinking about that, like trying to find an orthocenter. So let's see. Yeah, like in if we label this intersection point, like M is the orthocenter of FLC. I don't. So LM is perpendicular to FC. Or maybe we could use projective GEO too. So we want to show DH is parallel to IG. Is there anything we can project through I wonder if HE and K are collinear. I think they are, yeah. So if I move things around, oh, not necessarily, no. But yeah, I'm kind of thinking like if HD was parallel to JG, then we could project through H. So we could, I goes to F, but yeah, we don't know where E goes to. Let's see. So yeah, I feel like so what was it? HD is parallel to JG is what I was thinking. Let's see. So HD is parallel to GE. Maybe HD GE is a parallelogram? No. But it seems an easier problem to show that HD is parallel to GE, right? Like it seems like you could, because I and J are all created later, right? Yeah, I'm just going to delete these for now.
Yeah.
So yeah, we don't even really need I and J, basically. Like what if I hid a bunch of stuff? That's kind of just a more confusing way. Yeah, we want to show HD is parallel to GE. So yeah, ABCH is an isosceles trapezoid. Yeah, so you could kind of rephrase it. So you have an isosceles trapezoid ABCH, and then you pick another point in D. You draw the perpendicular to AC, then you draw the perpendicular to BC, and you want to show that GE is parallel to DH.
It just seems like an angle chase. I don't know.
Yeah, it feels like it. It certainly feels like it. So it's the same as showing AFEG is cyclic. Let me check that. And AFEG is cyclic. Yeah. Okay. So AFEG is cyclic, and from there, basically we have angle GED is FAH is FDH, so those are parallel. Yeah. Okay. So I will write it out. But I thought the Saudi Arabia test was hard, but we ended up getting through all the problems today. So wow, that's pretty good. Either we're getting better, or it wasn't that hard of a test. I don't know which one, but yeah, it was fun. All right, so let me write it out. So first, FEGA is cyclic, so that's not hard to prove. Let me move that over. So angle FEA is equal to angle FGA is 90. And so FEGA is cyclic. And so that means that angle EGD is equal to angle FAG, which is equal to angle FAH, which is equal to angle.
Oh, that's why.
Yes, is equal to angle FDH. And so EG is parallel to DH. Now let's see if I can remember how I got from there to showing that that's cyclic. Because then IJC is equal to CDH, which is equal to CFA. Yeah, that's pretty not too bad. So that means that angle IJH or IJC is equal to angle IJD, which is equal to angle CDH, because they're parallel, and that's equal to angle CFH, which is equal to angle CFI, and so CFIJ is cyclic. All right, so I think I am going to stop there. But for everyone who participated, thanks for joining. So I'm going to upload it to YouTube as usual. And yeah, it's kind of tricky to figure out the right difficulty for problems. So we got through all 7 of them today. And there was that one really tricky one. So maybe if we didn't end up solving that, then we would have thought it was hard. But yeah, I'm always trying to sort of figure out the right difficulty. So for everyone watching, if you like this video, give it a thumbs up and subscribe. And thanks everyone. So I'm going to end it right here.